Okay. Well, that was such a funny presentation before. I feel a lot of pressure on my shoulders now, but I'll try to do my best. So hi, everybody. Let's talk about crafting accessible components for component libraries. So before starting, my name is Mathilde. I'm a front-end developer at Shopify and also web accessibility specialist. On my day-to-day at Shopify, I work on no-code tools as well as accessibility and UI libraries. And that's why I'm very excited to talk about this topic today. So component libraries are crucial in most applications because they allow us to extract a lot of the presentation logic into a separate project. Best of all, they can be reused across multiple projects, ensuring a consistent look and feel through the system. Components in component libraries are like building blocks. They provide a solid foundation that can be customized to fit various situations. Luckily, many component libraries already do prioritize accessibility. They are built with accessibility in mind, and they put the effort to make components accessible. However, it's important to recognize that accessibility is context-dependent. This means that the same component may have different accessibility requirements depending on the specific context it's used in. Accessibility cannot always be tested in isolation. It has to be, the test has to be on a page as a whole. So as a result, it can be difficult for a library to accommodate every use cases. And as a developer, when your UI library does not fit your need, your main option are either to build the component on your own and not use it, and not use the library, but this means potentially breaking the style of your application and making it less resilient to future UI changes. Or you can modify the library to fit your needs, which is sometimes the right thing to do, but it might also not be possible or be an added overhead that's enough to discourage developers to commit changes. So that's why today I want to address this problem by sharing 3 patterns that can be used inside component libraries to give more power to the consumers and allow them to easily customize components to meet their accessibility needs. So let's dive in. The first pattern I want to talk about is to use a tag prop to allow consumer to choose the HTML tag that the component will render. So why that? One of the most prevalent accessibility issues is the incorrect use of semantic tag. Interestingly, this issue is also one of the easiest to rectify if you're working with HTML and vanilla JavaScript. But when you use React and component libraries, it's more complex because the same component could require a different semantic markup depending on context, and consumers are often not left with this level of control. Often the library determines what's the most appropriate tag, and most of the time it does fit. But when it does not, consumer has very little option. So to address this particular challenge, it's often advantageous to allow consumer to specify their preferred HTML tag for rendering. This can be achieved through usage of a tag prop. Sometimes you might see it called element or as, but it's basically the same principle. And how does that work? So let's look at this example for a card component. Card components tend to render an article tag, but there's circumstances in which article won't be appropriate, and maybe a section or a div tag would be more adapted. So to give consumer the choice, the first thing to do is to add a tag prop, whose intent is to determine the tag that will be rendered. In this example, the prop allows a list of hard-coded values, but you could be more permissive. It's good to use TypeScript here to make sure that only a valid HTML tag can be accepted. For the example, I also make this prop mandatory, but in many cases, you want it to be optional and have a default tag as a fallback. The second thing you want to do is to assign the value of the prop to a variable. For example, here we're going to name it component, and lastly, use this variable as a React component. And that's it. This way, the card will render either an article, a section, or a div, depending on what the consumer decided. That's a simple pattern to give consumers flexibility and select the most suitable HTML tag that best aligns with the requirements. The second pattern we're going to see is about extending components prop for area attribute support. The goal of this approach is to make it easier for consumers to define and apply area attributes to a component. For those who are not familiar with it, area attributes are a set of HTML attributes that you can add to elements and that help accessive technology to understand the page content. It can do a lot of different things, from saying that the button is disabled, that a form field is required, or list is expandable. They're really vital for enhanced accessibility, especially for screen reader users. And once again, when working with native HTML and vanilla JavaScript, using area attributes is super easy. You just have to declare them. However, with component library, if the component does not allow you to customize those, then you won't be able to configure them properly because they have to be put on the base tag of the component. So how do we make this process easier? Well, one way to do that is to make sure that components can accept any valid ARIA attributes and add them to the rendered element. So let's look at this implementation example. Here's the first thing that we do is that we make the component prop extend all ARIA attributes, meaning that all ARIA attributes will be valid props for this component. Then we use a REST parameter to collect remaining props into an ARIA attribute object. Here, this is not the safest thing to do, right? Because if the consumer doesn't use TypeScript, they can pass a lot of invalid attributes. So ideally, we need more checks at this point on the REST parameter. But for this demo, this is enough to get the point across. And so finally, we're going to apply this attribute to the element by spreading this ARIA attribute object. So this way, the consumer can add the required attribute to the component. For developers, this allows to more easily follow ARIA implementation patterns and to integrate them without the need to access or modify the implementation of the library. The third and last pattern we're going to talk about is exposing component ref using forward ref. So sometimes consumers need to directly interact with the DOM elements a component render. In the context of accessibility, it's often for managing focus, but it can be necessary for many other tasks, like scrolling to an element or accessing a text selection. And React has a way to allow us to access DOM elements. It's using ref. So to use ref, you need to create a ref using useRef. You pass it to your HTML element, here the button, and whenever you need to access the elements, for example, to focus it, you can rely on ref.current. This works well when you do have access to the HTML element. Let me drink a bit. So I think this works well when you do have access to the HTML element, but once again, in the context of component library, often you do not have access to the element. So if you apply the same ref implementation, but this time giving the ref to the component, the ref won't be forwarded to the underlying HTML element. And as a result, we won't have the capability to focus the element on demand. So that's why forward ref comes to rescue. Ref forwarding is a feature of React that lets some component accept the ref as prop and pass it further down, in other words, forwarding it to a child. To implement this in our button component, we need to first declare it using React.forwardRef function, which takes a function component as argument with 2 parameters, props and ref. And then we make sure that we give the ref to the HTML element. Now that the button component uses forward ref, the consumer will be able to create a ref and pass it to the component. This is great because this means that now we can focus the button or access it on demand. Exposing component ref is especially useful for interactive elements such as button or input. And that's it. We went through the 3 patterns. Before wrapping up, I'd like to put a bit of perspective on those patterns and address some potential drawbacks. So because the common point of all those patterns is to give consumers more control over semantic elements, over ARIA attributes, but it also carries an increased complexity and a potential for misuse, right? There's a valid argument that says that libraries should handle tasks like selecting ARIA attributes or choosing HTML tag and only provide consumers with pre-configured components. This argument has a lot to do with keeping the consumer code concise and encapsulating the logic within the library. On top of that, we also know that ARIA carries a risk of misuse, which raises concern about whether it's a good idea or not to give so much freedom to developers to apply attributes like this. I would say that my take on that is that I think it's worth to challenge the notion that restricting consumer control is absolutely necessary for improving accessibility. Especially as the library usage scales and the number of consumers greatly surpasses the number of maintainers. If you offer more control to consumers to apply accessibility features without altering the core library, then it's a great way to accelerate development while not compromising with accessibility. And that's it for me. Thank you for attending.